Okay, so here in lesson 2, we're going to learn about truth values of statements. We're going to learn about conditional and biconditional statements. It's kind of a loaded lesson, so please be sure to ask questions. We're going to talk about it often. We're going to bring these types of things back up. When you learn new theorems and you learn new definitions, oftentimes they are given to us as conditionals or biconditionals. And a lot of the really true properties about math that you know already are actually biconditional statements. You just don't realize you're kind of already working with them. In our warm-up here, you're just simply giving a true or false statement based on what you're given here. So take a second to read through these and then unpause here after you've answered to see how you do. Okay, so in the warm-up it says, if an object is red, then it is not blue. Well, that's true. It's really one or the other. Next one, if an object is not red, then it is not blue. Well, we don't know that's true. Just because it's not red does not mean it's not blue. It could be lots of other colors, but it also could be blue. If an object is not blue, then it is not red. Again, that's false. If an object is blue, then it is not red. That's true. And it says, rewrite this statement as true an if-then statement. An even number is divisible by 2. And again, here's kind of what we're doing today. So if you kind of struggled with 5, it's understandable, but hopefully by the end of the lesson, this is something you can tackle with ease. So it says if a number is even, then it is divisible by 2. If a number is divisible by 2, then it is even. So there's if-then statements. So our learning goals for today are to be able to write a compound statement using conjunctions and non-conjunctions and determine truth values, identify hypothesis and conclusion of conditional statements, and write and analyze biconditional statements. And again, as always, we'll have a practice set and reveal math. So kind of like last lesson, lots of terminology, lots of kind of trying to understand kind of the ins and outs before we dive into an actual proof. We need to understand statements and conjectures and all types of other truth values of these statements. So a statement is any sentence that is either true or false. So a statement is one or the other, but not both. Okay, a truth value is the truth or falsity of a statement. The statements are often represented using letters such as P and Q, and we'll discuss that more as we go forward. Okay, now one thing I do want to show you is the truth table. Now, in the past, students have really struggled with this truth table, and I don't know if your textbook will illustrate this at all, but if we have two sentences that interact with one another, it's kind of like two coins interacting with one another. So if I say I have two sentences, again, it doesn't matter what they are. It's just going to be two statements. The possible truth values for how they interact are as follows. We can have them both be true. Okay, so P and Q can both be true. And if that's the case, our output, P implies Q, or P arrow Q, is also going to be true. We could have a true statement, then a false statement. Okay, that's going to give us a false. Now, here's the one that the kids kind of have a hard time tackling. False implies a true statement is still going to be true. And then false implies false is also going to be true. Now, we'll talk more about this later, but I just wanted to go over this. So don't even worry about getting this in your notes or anything, but these are the possible outcomes for truth values. You can have true, 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 false, false, true, or false, false. It's kind of like flipping heads or tails with two coins, heads, tail, or heads, 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 tails, tails, heads, and tails, tails. Okay. Now, kind of what we're going to deal more with today is truth statements. Again, if a statement is represented by P, then not P is the negation. So that's the first thing we need to understand, is that the negation is just going to add the word not into our sentence. So like what we saw in the warm-up, if it says red, a ball is red, well, the negation of that statement is simply the ball is not red. If my statement is P, the ball is red, then negate P is the ball is not red. That's all that means. It's going to be part of what we do today in terms of understanding truth values. Okay, so two or more statements joined by the word and or form what's called a compound statement. So if, again, you want to add compound statement to your notes, it's two or more statements joined by the word and or. says a compound statement using the word and is a conjunction. So an and compound statement, is called a conjunction, and it's only true only when both statements that form it are true. So both of the statements in a conjunction have to be true in order for P and Q, this notation right here, in order for that to be true. However, a compound statement that's a disjunction, okay, is the or. Okay, so the or one is called a disjunction, and it's true if at least one of the statements is true. So if one or the other in P or Q is true, it's going to be a true statement. So now, again, with geometry, we haven't got a whole lot into stuff, but let's talk about some statements here. So we have 3 statements based on what's going on. It says, use the statements to write a compound statement for each conjunction, then find the truth values and explain your reasoning. So P, the figure is a trapezoid. Based on what we see right here, we know a little bit about trapezoids, and one thing that's true is the opposite sides are parallel. Okay, so this is a trapezoid, but we can be more specific than that. So we're going to say false. Okay, this is not a trapezoid. This is a square. This figure has 4 congruent sides. Well, based on the markings alone, we can see that that's true. This has 4 congruent angles. This is also true. So part A wants us to say, okay, what is the truth value of P and R? So if I look at the truth value of P, it's false. But if I look at the truth value of R, it's true. Because it's the word and it's the conjunction, the truth value of that. So although R is true, P is false. So the truth value of P and R is false. Okay, looking at the next one, if I say negate P, so now again, the opposite, this figure is not a trapezoid. Well, if the statement itself is true, the negation of the statement has to be false. So if P is equal to true, if P is equal to false, negate P must be true. Okay, so the negation of P is true and Q is true. So P and Q in this figure are both true, so the statement is true. Okay, again, we'll spend more time with this. We're going to talk about a disjunction now. So again, negation, just as the opposite of an integer, the is not always negative. The negation of a statement is not always false. The negation of a statement has the opposite truth value of the original statement. Okay. So when we negate a the negation of a statement has the opposite of the truth value of the original. We have to keep that in mind. Use the statement to write a compound statement for the disjunction P or R. So P or negate R. In this right here, we have this image down below. It says angle ABC and angle CBD are complementary. Again, complementary is a key term, but that is not what those are. ABC and CBD are not complementary, they're supplementary. So this is false. Angle ABC and CBD are vertical. So again, looking at this right here, those are also not vertical angles. Okay, now if we look at the only thing that we do know is true about this so far, AB is congruent to BD, that is 100% true. So now if I have to look at the truth value of this. Now the negation of R, AB is not congruent to BD is false. Okay, we know that for sure. So P or R, if I look at P is false. It's not complementary, it's supplementary, or AB and BD are not congruent. So P or R is false because not only is the P false, okay, so because P is false, and because the negation of R is false. Now keep in mind, if one of those statements was true, because it's an or, it can be a true statement, but it could be one or the other. It can't be neither. Okay, so now conditional statements are a little bit different. Those are truth values with conjunctions and disjunctions. Conditional statements is a compound statement that consists of a premise, a hypothesis, and a conclusion. which is false only when the premise is true and the conclusion is false. So again, this conditional statement is going to have this notation like we talked about earlier. It's going to have a premise or a hypothesis, and it's going to have a conclusion. And what this is saying is that as long as it's not true implies false, okay, as long as it's not true implies false, it's going to be a true statement at the end of the day. So when true implies true, it's going to be true. When true implies false, it's going to be false. When false implies true, now this is the one that students kind of trip up on, it's still true. And again, it's because of this, only when the premise is true and the conclusion is false. And then when false implies false, it's still true. Okay, so now here's what this looks like in terms of sentences. We're going to write them in if-then form. We're going to say, if my hypothesis, then my conclusion. Okay, and I'm going to kind of summarize this, but I like the example the book gives here too. So the hypothesis in this example that the book gives is if it rains. So the hypothesis is it's going to rain. The conclusion is the parade will be canceled. So the conclusion is the parade will be canceled in green. So the hypothesis, again, is not the if part, but again, it's just the part that's in orange. You can see that there. Make some sort of indicator that it's not the if, it's the stuff that follows the if. So if it rains, then the parade will be canceled. So the truth value of that is going to be probably true, right? If it's going to rain, true, the parade will be canceled, true. So when we go to look at these, hypothesis implies conclusion, we can say that this is a true statement. It doesn't always have to be math stuff, okay? The converse of a conditional statement, and what you need to highlight here is, again, your conditional statement is going to start out like this every time. P implies Q. Okay, the converse of a conditional statement is this. Q implies P. So if I look at my conditional statement up above, it was if it rains, then the parade will be canceled. If I flip that, that's the converse. It says if the parade is canceled, then it has rained. Okay, so again, that might not be true. You could have a case where the parade could be canceled for lots of reasons. Maybe there was an accident or whatever, but pay attention to the truth value, especially when we get into the math stuff. We have to make sure that we make sense. Okay, the next one is called the inverse. So again, the converse was Q implies P. The inverse is negate P implies negate Q. And again, keep in mind up above, the negation is simply we include the word not. So if it does not rain, the parade will not be canceled. Okay, so again, it's just writing it out as a compound statement with if and then. And then lastly, add to your notes the term contrapositive and put negate Q implies negate P. So the parade is not canceled, then it does not rain. Okay, so the premise all starts with our original conditional statement, and then we basically manipulate past this P implies Q and understanding what our hypothesis is and what our conclusion is, and just putting the word not in them and moving them back and forth. Again, we'll have lots of practice, ask lots of questions. It seems overly confusing, but once you get the hang of it, I promise it's very simple. Okay, so here's an example. And again, this is a great example because we know this to be true. This is something that we can really wrap our heads around. So it says, identify the hypothesis and conclusion of each conditional statement. So again, the hypothesis is a polygon has 6 sides. The conclusion is then it's a hexagon. So it says if a polygon has 6 sides, there's our hypothesis. A polygon has 6 sides, then it's a hexagon. There's our conclusion. Okay. Another performance will be scheduled if the first one is sold out. So again, if is in the second portion of the sentence. If follows if is followed by the hypothesis. So if, again, the first performance is sold out, okay, then another one will be scheduled. Okay, and again, I've never taught it where if is at the second part, just to keep it uniform. Your questions on your quizzes and tests, they're going to look like this. It's going to be an if then form, just to keep things straight. Okay, so again, doing numbers, doing the skill check here, make sure you try it, but keep in mind, it's going to probably, every time you see one, is going to be written like this, especially on an assessment, just to keep it straight. So again, the hypothesis here, forecasted rain. Okay, the conclusion is take umbrella. Okay, the next one is, again, if, again, last digit 0. The conclusion, divisible by 10. Okay, and again, this is something we know to be true. If it's divisible by 0, then it's divisible by 10. Write a conditional statement in if-then form. So again, we're going to take a conditional statement. 4 quarters can be exchanged for a dollar bill. We need to pull apart a conclusion and a hypothesis based on this. So again, if you have 4 quarters, then you can get change for a dollar bill. So again, if you have 4 quarters, then you can exchange them for a dollar bill. This one says the sum of the measures of 2 supplementary angles is 180. So again, if, well, we don't want to include if, so we can say angles are supplementary. Then the conclusion is angles sum 180 degrees. Okay, so again, kind of abbreviating it here for time. If angles are sup, then sum 180 degrees. Okay, so again, pause, take a second, try to write out your hypothesis conclusion. I'm going to go quick because of time here. So the statement is a quadrilateral with 2 sets of parallel sides is a parallelogram. So it sets of parallel sides, and then it says quad is parallelogram. Again, that's not an 11, that's parallel lines there. I'm not trying to make it confusing, I'm just going quick. So again, if sides are parallel, then quad is parallelogram. Not an 11 gram, a parallelogram. Going quick. Okay. So again, ask questions, but that's how it goes. So kind of the same thing, you guys. I'm going to keep it pretty basic. I'm going to skip over example 5 for now, and we'll talk about truth values, but we're going to make it more specific to stuff that's very much more cemented in what we can do and understand. I'm not going to worry about salt water and fish and woodwinds and all that stuff. I want to keep it more related to math or more things generalized that we understand. So the last term that we're going to talk about today is a biconditional statement. So what happens is if you have the truth statements or the truth values of both the converse, inverse, and contrapositive, along with the original conditional statement, if all of them are true, then you can write what's called a biconditional statement. Okay, so if all of your statements are true, once you're all said and done with what's going on, if everything is true, you can write what's called a biconditional statement, and you can put the if and only if term in the middle. So rather than seeing if, comma, then, you're going to have a statement, the hypothesis, and then the phrase if and only if, and then the conclusion. Okay, so the biconditional statement, if you read through this up above, take a second, pause, and read through the if-then statements right here in this middle portion. But if these statements are both true right here, what you can do is you can write this biconditional statement. It's Aaron will be accepted into the culinary school if and only if he earns a 3.5 GPA or higher this semester. Okay, so that's what it looks like rather than having if in front and then in the middle. Okay, they take that if and then away, and it's if and only if in the middle for a biconditional statement. Okay, so again, I'm going to kind of do something a little different rather than messing with that. Let's talk about something that we know to be true. So let's say we have the conditional statement that if angles are complementary, then they have a sum of 90 degrees. Okay, we know that that's true. We also know that the converse, inverse, and contrapositive are true. So what we want to do is we want to say, because these statements are all true, if it's 90, if it's a sum of 90, then it's complementary. If it's complementary, it's a sum of 90. Again, the nots work the same too. If it's not complementary, it's not a sum of 90. If it's not a sum of 90, it's not complementary. All those things are true. So we could really write out all those, and let's just do that real quick. So here's the original. Okay, the converse is if sum 90, comma, then comp. Okay, and then the inverse of that statement would be if angles not comp, then sum not 90. And lastly, the contrapositive, we have if sum not 90, then angles not comp. Okay, all of those statements are true, 100% true. So because that's the case, we can write a biconditional statement. The biconditional statement is this: angles are complementary if and only if. So you'll see this little phrase sometimes in math, or you'll also see these double-sided arrows. So rather than just the implies, you'll see both sides of the arrow. So keep that in mind. If you see both those arrows like that, that's what that means. So angles are complementary if and only if they have a sum of 90. Okay, so there's a perfectly good example rather than throwing all these other weird cases at you where it's talking about an individual studying or woodwinds and brass and all that kind of thing. Let's pull it down to something we know is true about geometry. So there's our biconditional example. Again, I know I went quick for the sake of the video, just so that, again, it doesn't have to upload for too long, but take a second and pause this, try this check. Make sure you can kind of understand what's going on. So our conditional statement, isosceles triangles have at least two congruent sides. I'm going to go through this quick. Our conditional is if iso, comma, then two congruent. The converse is if two congruent, comma, then iso. Okay. Those are both true. So if those two specifically, if those two in a row are both true, the conditional statement is true, the converse is true, you can write a biconditional. So isosceles, a triangle, so we'll put a triangle is isosceles, a triangle is iso, if and only if two congruent sides. Okay, we will probably do one of these on a quiz, one of these on a test, because they do take some time to write out. But again, understand the truth value has to be the same, especially for those two consecutive ones. Okay, so again, don't worry about the rest of this. If you want to take a second to try the exit ticket, but notice there's stuff going on that's not really math related or specific, but there are quotes. But you can sure try that if you pause it and try those really quick. Here's your solutions. Again, take time, ask questions. Please be sure that you understand what's going on with conditional and biconditional statements, as well as your injunction and disjunctions. Those are going to, or excuse me, conjunctions and disjunctions. Those are going to be some things that we briefly touch on and kind of build on as we go this chapter.